So for this part, we are going to look at how we find the area of a parallelogram with adjacent vertices, and then these are the vertices. Now, if you look at the formula that we came up with, was if you have two vectors u and v, these are two vectors which are adjacent. So you have one vector, maybe this is a vector v, u, and then you have your second vector, v. We sought to say that these can be used to obtain a parallelogram that you form by completing it like that. And the area here, we sought to say this area could be calculated using two methods. We can either calculate the area by just saying the magnitude of the first vector multiplying the magnitude of the second, and then sine the angle between the two vectors, which is that angle there. Or we can just get the cross product, u cross v, and then just its magnitude. So these are the two methods that we saw that we can use to obtain the area. But if you look at the two problems 7 and 8, we see to say that in this case, we're not given the two vectors u and v. Instead, they've given us the vertices of the parallelogram. What is this? So it's like this. So these are adjacent, so it doesn't really matter how you pick these, but basically they are adjacent. So I can take this vertex here to be, let's say, -2, 1, 0. And then I can take this one here to be 1, 4, 2. And then I can take this one here to be -3, 1, 5. So it doesn't really matter how you pick these, but basically, you know, to say a parallelogram is going to have 4 vertices, the order here can be anything, but all in all, the question specifies these are adjacent, so meaning they come one after the other. So if this is how, of course, I was just putting them randomly. Of course, these are going to be in 3 dimensions, so they're not really going to be something like this. Here I was just presenting them like this so that it's easy for us to see, to say one is there and so on. So how do you work out the problem? Well, first you need to come up with the two vectors, one that will be represented by u and the other that will be represented by v. So to get these two vectors, you know how it is, you're given positions. So from the positions, you can easily get a displacement vector. So the displacement vector u, I can say it's coming from here, going up to that point on top. So, you know, it's where you're starting from minus where you're going. So this is going to be, as in where you're going minus where you're coming from. So it's going to be -2, since we're going to that point, minus, we're starting from 1, in the I, plus, next it's going to be 1, -4, j, then plus, 0, -2, k. Now, since I've put this point to be the one on the middle, meaning that from here, I'll go to this one here. So this is how it's going to go. So now my vector v is going to be -3, -1, I, plus, next we're going to have 1, -4, j, and finally 5, -2, k. Now we can simplify these. From the first one, we end up with u is equals to, so this is going to be -3, I, -3, j, then -2k. And then v will be equal to, this is going to be -4, I, -3, j, and then plus 3k. So we have the two vectors. After getting the two vectors, we can now get the area. Since we're just going to use, in this case, we don't have the angle between them, so we can just use cross product. So this will be equal to the magnitude of u cross v. So in this case, this will be equal to, so you know how you get cross product, similar to what you did in CEE. So first here, you're going to have ijk. So first, it's like I'm just concentrating on just the cross product, not necessarily the magnitude part. Let's concentrate on cross product. So for starters, I'm first just going for U cross V. So to get U cross V, I'll use the determinant method. I, J, K. From U, I have minus 3, minus 3, minus 2. From V, I have minus 4, minus 3, plus 3. Using the determinant method, I will leave us, so this and this out. So you have negative 3 multiplying 3, minus 9. Then minus negative 3 by negative 2, we get positive 6. So get this. Then minus J. Now, when it comes to J, we are holding this and this. And this is going to be minus 3, positive 3. We get minus 9. Then minus 4. So this is minus first. Minus 4, minus 2, positive 8. Then plus K. And then, of course, we see how it goes. Now we're holding this and this. So this is going to be minus 3, positive 9, minus 4, minus 3, positive 12. So from here, this is minus 15I. Then this is minus 17. Then positive there, positive 17J. And then 9 minus 12, that is minus 3. So this will be minus 3K. So this becomes our U cross V. Since we now have U cross V, now we know to say our area will be U cross V, but just the magnitude. So we now want to get the magnitude of this vector. How do you get the magnitude? To get the magnitude, so U cross V, just the magnitude will be equal to the square root of, the first is minus 15 squared, 17 squared, and then we have minus 3 squared. So this becomes the square root we are evaluating. So we get 20.74.
Oh no, that's 17, yeah?
This is 17, minus 15 and 17 there. It's not 20.7?
It's 22.87.
0.87. Okay, so yeah, you guys can verify this. So these are units squared. Okay, so that becomes the area. Great. So other than this, so that concludes question 7. Now we move on to question 8. In question 8, calculate the area of a triangle with vertices this and that. So here we're now going for a triangle. So since in question 8, we're now going for the area of a triangle, not a parallelogram. In question 7, we're looking for the area of a parallelogram. So here, well, again, I keep using diagrams for 2-dimension because they're easy to relate to. For me to start sketching a 3-dimensional picture here might be difficult for us to relate to. But let's look at where a triangle comes from. Or let's start with a parallelogram firstly. If you recall the parallelogram we had earlier, we had something like this. So now just copy this. Then this is what comes there in a parallelogram. And we get this one. So this is what goes the other side in a parallelogram. Okay. So this is a parallelogram. But if we wanted a triangle from this one, how would a triangle look like? So to have something similar, but now if this is to be triangle, notice that it would just end somewhere here. My point is, even a triangle can be seen to be a piece of a parallelogram. You see, since they've given us the vertices of the triangle, it's like they've given us this point, and this point. But these points can be seen to be vertices that were part of a parallelogram. So in other words, a triangle can just be seen as half of a parallelogram. So our approach to getting the area of a triangle given the vertices will just be similar to, we'll just start first by getting the area of a parallelogram. So for a parallelogram, we sought to say the area was just the magnitude of the cross product. This is how we got the area of a parallelogram. But to get the area of a triangle now, a triangle will be half of the parallelogram. So we'll just half this. And what we'll have will be the area of the triangle with those vertices. So what do I mean? So let's look at our problem here. For this problem, what are our vertices? We have that's 3, 1, 7, and then we have 2, minus 1, 4, and then we have 7, minus 2, 4. Here again, the assumption is that these are going to be adjacent vertices, of course. So let's complete this one like that. Okay, so let's go the other side. So they start, basically the approach we use, as you saw, it's similar to what we did when we're dealing with a parallelogram. The only difference is we're just going to have our final solution. So we're going to have, we can just, from these, if you want a simple picture of what is happening, it's like you have one vector, u. Again, these are not exact, just for us to relate to. So you have one vector, u. So we're given the vertices. I can take this to be 3, 1, 7. And then here we have 2, negative 1, 4. You have to see that here, regardless of how you arrange these 3 points, it will still be the same. The results would still be the same. So you can arrange them however you would want, and you still get the same answer. So point number 3 will be somewhere here. Okay, so the only key thing is, once I start, when getting u, if I put my vector to say it's starting from here going upwards in that direction, then I must not take this to go backwards here. I think given that we're just going for the magnitudes here, I think it wouldn't affect much. I think you guys can try to play with it. For safety, I just like starting my vectors from the same point. So this goes up. So since I'm going to that point, this is my final point. So it's going to be final. I have 3 minus 2 in I, plus I have 1 minus 1 for j, and then plus 7 minus 4 for k. When I complete this one, I have I, then here I'll have plus 2j, and then here I'll have plus 3k. This becomes my u. We get the second vector. My final is this one. My starting point is this one. So final minus initial, 7 minus 2 for I, plus minus 2 minus 1 for j, and then plus 4 minus 4 for k. So here we end up with 5i. Then this is minus minus positive, so minus 2 positive 1, so that will be minus j. And then that is 4 minus 4, that is going to be 0. So I can leave it like this. So we now have the two vectors u and v. First thing, we'll get the cross product of the two vectors. So the cross product, again, we're using the determinant method, I, j, k. So from U, we have 1, 2, and 3. 1, 2, and 3. From V, we have 5, minus 1, and 0. So when we cross here, we get I. When we hold I, we have 2 times 0, that is 0, minus negative 1 times 3, that will be negative 3, which will make this positive 3. Then minus J. When we hold J, we now have 1 times 0, that will be 0, minus 5 times 3, that will be 15. Then plus, now we keep K, it will be 1 times negative 1, giving us negative 1, minus 5 and 2, giving us 10. When we simplify, this will be 3i, then this will be plus 15j, and then this will be minus 11, so this will be minus 11k. So we now have the cross product. So let's get the magnitude of the cross product. So the magnitude of U cross V will be equal to the square root of 3 squared plus 15 squared plus minus 11 squared. So be very careful on how you evaluate that one here. Some students end up making mistakes there. So the negative will be swallowed by the square here. So you might as well just take it as 11 squared. So what will be the solution when you square root there? So you're saying 18.84. Okay, so others can confirm this. So once you obtain the magnitude there, we can now go for the area that we want to find. Our area, we so to say for a triangle, it's half of this magnitude. So this is just going to be half of 18.84. So that finally, this is just going to be half of 18, that is going to be 9.42. Okay, so that becomes our area.